Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTA 2311 Signals and System Analysis. In this video, I will show you the solution to sample problem 1 related to Fourier series. In this question, you are asked to determine the trigonometric Fourier series representation of this signal, which is a square pulse periodic signal. Okay, so the first step that you wanted to do is to determine the period, which is t, the frequency, and also the radian frequency. So the period, if you look at the graph over here, okay, the period is 2 seconds. Okay, because the signal is repeating the same pattern every 2 seconds. This is 2 seconds. The frequency here is 1 over t, so this is 1 over 2 Hertz. And the radial frequency is 2 pi over t. So this is 2 pi over 2. It will give you pi radian per second. Now the trigonometric Fourier series general equation is given by this. A0 plus summation from n equals to 1 until infinity for an cos n omega ot plus bn sin n omega ot. Okay, so now we need to determine a0, an, and bn. For a0, we calculate using this formula: 1 over t integration over the period for f of t dt. Okay. So now if we look at the graph here, the signal here, we can see that for this signal, okay, f of t, the definition is the signal is equals to 1 when t is in between 0 to 1. And here, the ft is 0 when t is in between 1 to 2. So you can take another period, let's say from minus 2 to 0, but you will still get the same definition. Okay, where ft is 1 in between minus 2 to minus 1 and 0 in between minus 1 to 0. So you can take whichever period, or you can take, let's say, from 1 to 3 seconds. Okay, so it's up to you. But the definition, if you take from 1 to 3, then from 1 to 2, f of t is 0, and then from 2 to 3, ft equals to 1. Then you can substitute into the integration over here. So if I take this range and I substitute this, a0 equals to 1 over the t is 2, then I will have integration from 0 to 1 second. My f of t is 1 dt plus from 1 to 2, my f of t is 0. Okay. So this part, the whole will be 0. So I am left with a0 1 over 2. If I integrate this, I will get t 0 to 1. So it will be half 1 minus 0. So a0 is half. Okay. And an, let's just draw a line over here. Okay. An is calculated using this formula, 2 over t, it's integration through the period as well, f of t multiply with cos n omega ot dt. So an equals to, you have the t is 2, so again you integrate from 0 to 1, f of t is 1. Okay, cos and omega is pi, so we can substitute here pi t dt plus 1 to 2. Here f of t is 0. So actually the whole thing is 0. So an equals to, this one will cancel out and become 1. So you are left with the integration over here. So if I integrate that, I will get a sine. Sine n pi t. Integrating cos, you get sine, and then you integrate the n pi t with respect to t, so you will left with n pi 0 to 1. This one equals to 1 over n pi. This is sine. You substitute t with 1, you are left with n pi minus sine of 0. Okay. Now this sine of 0 is 0, no problem. So we need to find this sine n of pi. Now this one, you have to refer to the table that I show you in the video where I discuss Fourier series. Okay, so if I find that table, let me just quickly open my notes. It's this table. So here we have sine n pi, the value is 0. Okay, so if I go back to my slide over here, so sine n pi is 0. This is also 0. Okay, so I am left with an equals to 0. Okay, now for bn, equals to 2 over t, again integration over the period, f of t, this one multiplied by sine n pi t dt. Okay, so we still use this definition of the signal. Okay, so you will have bn equals to 2 over 2, if 0 to 1, f of t is 1, plus 1 to 2, f of t is 0. Okay, so this means that this part, the whole thing is 0. And bn, this one cancel out and become 1. And if you integrate this part, you are left with this. If you integrate that, you will get integration of sine is minus cos n pi t, and then you integrate the n pi t with respect to t, you are left with n pi from 0 to 1. Okay, so this one equals to 1 over n pi. Now if I substitute t with 1, left with cos n pi minus cos of 0. Cos of 0 is 1. Right? Then the cos n pi, we have to again refer to the table. So the table here, cos n pi is minus 1 to the power of n. And so if we substitute that here, minus 1 over n pi This one is minus 1 to the power of n minus 1. Okay. Or we can rearrange because we have a negative at the front here. So we can rearrange so that this becomes positive n pi. Now this minus 1 will become positive 1. And this positive will become negative 1 to the power of n. Okay. So we can substitute this bn and an and also a0 into this general equation of the trigonometric Fourier series. So we will have the representation of the Fourier series as such. A0 is half plus an is 0. Okay, an is 0, so we don't have this cosine part here is 0. Okay, this part is 0 because an is 0. Okay, as determined here. And we are left with bn, which is one over n pi 1 minus minus 1 to the power of n sine n omega ot. Okay. So this is the trigonometric Fourier series representation of this square pulse periodic signal. Okay, and actually this bn, see if I can change the color. This bn is, okay, let's say if you substitute this n with 1, so you have, say, b1, you will have 1 over 1 pi. Here is 1 minus 1 to the power of 1 is minus 1. So you have 2 over pi. So let's say if we have b2, so we have 1 over 2 times pi, 1 minus. Now, minus 1 to the power of 2 is positive 1. So you have 1 minus 1, this whole thing will become 0. So b2 is 0. Now if we repeat, let's say b3, you will have 3 pi, 1 minus 1 to the power of 3 is minus 1. So here you have 2 over 3 pi. Now if you calculate b4, it will be 0 again. So actually bn, by definition, is equals to 2 over n pi when 0 is odd. When n is odd. And let me see if I can find the eraser. Cannot. N is equals to 0 when n is even. Okay. So this is the answer to this question. I will see you in the next video for solution to sample problem number 2. Thank you.